Good afternoon, everybody. Welcome to today's Intro to Kubernetes and Rancher training session. I am your host, Adrian Goins, and we're going to get started. If you're a person who uses Twitter and you want to tweet about today's training, you can use the hashtags RancherTraining and RancherKates. And if you want to connect with me after, well, not during, because I'm actually talking, you can find me on the Rancher user Slack as Adrian, and then there's a whole bunch of other methods there. You'll actually get a copy of these slides and a link to the video after the whole thing's over. So, you can find me after that. I always go long with these things, so I'm going to burn through this intro and housekeeping stuff, and hopefully we'll end on time today. So we've got some stuff that we're going to do. Most of today's training is actually command line Kubernetes. So we're going to jump into installing K3s, and then I'll go through all sorts of stuff with Kubernetes and Kustomize and infrastructure as code and give you a good solid foundation in how to do stuff with Kubernetes. And then we will install Rancher, and we'll run through an overview of what Rancher can do for you. Sometimes there's more than just me here, but since there's only me today, we will do Q&A throughout the entire class. So if you open up the questions panel on the GoToWebinar panel thingy that you've got on your desktop, you can send your questions there. And that's also the place that you tell me things like, hey, you're still listed as your name is Matthew Shear, or your audio's messed up, or whatever, things like that. I keep an eye on that, and occasionally, because GoToWebinar is what it is, sometimes there's issues. Hopefully not today. You don't have to have any Kubernetes experience whatsoever, but you should understand basically what containers are and how they work. But you know what? Even if you don't have any experience whatsoever, you'll still learn stuff today. You can follow along with me. In fact, let me trade out this little news crawler there. You can check out this repo, and literally there's a README file there that I have up on my screen that I copy and paste from. So you don't have to write this down right now. It'll be scrolling across your screen in just a second. Rancher has tremendous resources available for you. You can get our documentation from rancher.com/docs, and you can also find support in the Rancher users Slack. I don't really like that URL. If you don't have an invitation, you can go to slack.rancher.io to get one, but it's actually rancher-users.slack.io if you already have a login. If you go to the link that's there, there's also a link that you can click on to go to whatever. Once you're there, you know how to find Slack. Slack's really good for real-time support. There's literally tens of thousands of people registered, thousands of people online at any moment, all of whom want to help you succeed. But if you're looking for longer term things, you can also check out the forums. People post questions there. And both of these locations are monitored by myself and other Rancher engineers, as well as members of the community. We do get people in this class who don't actually know anything about Rancher. So if you give me a couple minutes, I want to lay down a foundation of what our objective is as a company, as a producer of software, and how we see you can be successful with Kubernetes. Basically, there are two key pillars for a successful Kubernetes strategy: certified Kubernetes distribution and centralized management. Certified Kubernetes distribution is critical to enable compute everywhere. If you want compute everywhere that you need it, you need to deploy CNCF certified versions of Kubernetes. That be in the data center, in the cloud, desktop, branch, edge, wherever. But once you have Kubernetes, you need something managing it for you to do the heavy lift of the day-to-day operations that free you up to focus on the things that matter. Those things are consistent cluster operations, security policy and user management, and shared tools and services. On those two things, you can deploy all of your applications with automation or whatever tools you want, and you will be successful. Now, of course, Rancher has solutions for these things, but you don't actually have to use our products to be successful. We hope that you do. Our stuff is 100% free and open source, and you can't go wrong if you use it. But if you choose to use something else, you'll still be successful. For certified Kubernetes distributions, we have two: RKE, which runs everything inside of containers and is designed for data center environments, and K3s, which is what we're going to use today. K3s is super lightweight, works just as well in a data center as it does in resource-constrained environments like IoT and the edge. Our flagship product, Rancher, handles the management layer. It's the most popular Kubernetes management solution with over 100 million downloads right now, and it's 100% open source. It enables production quality Kubernetes everywhere by delivering on the things I mentioned a moment ago. For consistent cluster operations, it provides simple, consistent cluster operations. I don't know why I'm repeating myself. It includes provisioning, version management, visibility and diagnostics, monitoring and alerting, and centralized audit. For security policy and user management, it enables you to automate processes and apply a consistent set of user access and security policies for all of your clusters, no matter where they're running. And for shared tools and services, it provides a rich ecosystem catalog of services for building, deploying, and scaling containerized applications, which includes app packaging, CI/CD, logging, monitoring, and service mesh. We're going to work with K3s today. It is super lightweight. It runs all of the Kubernetes components in less than 512 megabytes of RAM, which means you can deploy it in resource-constrained environments and still have RAM left over to run your actual workloads. It's different from non-production solutions. It's designed to be a lightweight, production-grade, multi-node Kubernetes cluster that you can run pretty much everywhere. The installation process for K3s from us suggests that you go to each of the nodes and launch the K3s binary, but Alex Ellis, who's the guy behind OpenFaaS and Inlets, created a tool called Ketchup, which is what we're going to use today to actually do our installation. It's pretty simple. You run Ketchup install, you pass it the IP, and you pass it the user that you want to SSH in as, and optionally, you can pass it a K3s version. Ketchup has versions of K3s bundled with it, not the actual binaries themselves, but a particular version of Ketchup is designed by default to deploy a particular version of K3s. And if you want to run a different version, you just tell it K3s version. What this does is it SSHs out from my desktop here into the node and then performs an installation of K3s. It will then bring back the Kubernetes configuration file that we use to talk to the cluster. It presents it out on the screen there, but it also saves it locally as a file called kubeconfig. If we set our kubeconfig environment variable to point to that, we'll be ready to talk to the cluster. Now, I use the fish shell. If you use bash, your format is going to be something more like kubeconfig equals kubeconfig. That would be for all of you bash users out there. So we have a Kubernetes cluster. Wow, that was fast. One of the greatest things about K3s is you can literally go from 0 to talking to the cluster in less than a minute. And now we can talk about Kubernetes. Kubernetes is powerful and it's flexible. And when you're just getting into it, it can be a little bit scary. But really all it is a way to assemble components, blocks, building blocks, bricks, whatever analogy you want, into applications. By the end of today's class, you will know everything you need to know to go out and start running applications with Kubernetes. With this basic set of knowledge, you will be able to expand upon it in whatever direction you need according to the workloads that you're deploying. You might go down the path of learning how to do persistent storage, or there's any number of places you can go in your Kubernetes journey, but all of them start with these things: pods, replica sets, deployments, ConfigMaps, services, and ingresses. A pod is the smallest unit of thing that you can deploy in a Kubernetes cluster. Kubernetes has this lexicon. It's got a different way of talking, and that freaks people out. I'm going to get all casual with you guys here. Pods are simply a logical representation of multiple containers. If you've done anything with containers where you need two containers to talk to each other, you've got Apache and PHP or whatever fast CGI going on, or a web application and a database application, you've run into problems around networking. Pods solve those problems by grouping containers together so that they're scheduled onto the same host, and so that not Well, so the containers within a particular pod are scheduled in the same host, and containers within a particular pod share network space, storage, and some other stuff that's not relevant to today's class. Throughout the class, you'll hear me refer to that. I'll be like, oh yeah, it does this other thing, but we're not going to talk about that today. Pods bundle containers together with shared network space and shared storage. So two containers can talk to each other on localhost. One container can write to the disk and the other container can read the file. It solves so many problems around inter-container communication. Each pod gets its own IP address. They're wonderful. Here's an example of a pod with two containers. There's a file puller that brings down content from some CMS, and then there's a web server that pulls that content off the disk and ships it out to consumers. This is a good representation of how the containers in a pod should be related as a unit of your application. Together, the containers allow the pod to do a thing. You wouldn't, for example, bundle a web server container with a database container, because when your application needs more horsepower, you're going to scale up the number of pods. Pods are also called replicas. You'll scale up the number of replicas. You'll go from 1 to 2 to 5 to 10. And you want to make sure that the thing that you're scaling is relevant to where you need more power. If you were to go from 1 pod to 10 pods because you need more web servers, you wouldn't also need 10 database servers or 10 application servers or whatever the thing might be. When you have stuff like that, you'll split them out into multiple pods and set up a microservices style communication between them. Everything in Kubernetes happens with YAML. YAML's the next place that people freak out. You look at these things and you're like, oh my gosh, how am I ever going to remember all of this? And you're not, and nobody does. You will develop systems to copy and paste these, to generate them dynamically, and I'll show you a number of different ways today to generate this YAML. But like everything, before you can understand the shortcut, you need to understand what it's doing. Here's a spec for a pod. It's got 4 top-level keys: API version, kind, metadata, and spec. API version tells Kubernetes where in its API definition it can find information about the thing that you're asking it to create. In this case, that thing is a pod. Metadata we talk about later. Spec defines the thing itself. The pod spec provides for a key called containers, and then underneath there is a list. In this case, we just have one container. Its name is myappcontainer. It's going to run the busybox image, and we are going to override the default command for the image with this command here. There it is. I just changed the command slightly so that it sleeps for 1 second instead of 10 seconds. And I don't know why I haven't updated the slide. In fact, you know what? I'm just going to go update the slide right now, because every single time I do this class, I'm like, oh, I haven't updated the slide. And all right. Now I've updated the slide. Make sure my sharing still works. Good. I'm going to apply this to the cluster with kubectl apply -f. Now, kubectl is the command that you use in the terminal to communicate with a Kubernetes cluster. There's lots of things that you can do with it. You'll see that I have abbreviations that I type, like, KGNO, that for your benefit, I expand out automatically to kubectl get nodes. But the more you type this stuff, the more you realize that you need to have shortcuts for it. A lot of people abbreviate kubectl to just K, or they'll have KGPO or whatever. In this case, we're going to use kubectl apply -f, and we're going to point it at the manifest that we want it to apply. And it says, great, I have done so. Now we're going to say kubectl get pods. And it's going to tell us that, hey, there's a pod. Now I want to pass it -w so that it continues to monitor this, and whenever there's a state change, it will update it for us. And you can see right away that the status has changed from completed to crash loop backoff. Well, you see, Kubernetes expects that unless you tell it that the thing it's running is going to run once and exit, that thing should stay running. So in our case, we just have it printing out a command and then exiting. Kubernetes doesn't know that it's supposed to exit, so it restarts it. 1 second later, it exits. Kubernetes restarts it, and it exits. And after a couple of times, Kubernetes says, well, okay, hang on. Clearly, there's a problem with our relationship. I'm asking you to do something, you're not doing it, so I don't know why, but I'm just going to give you some time to think about it. And it waits before it restarts it. That's a crash loop back off. So it's in a crash loop, it's backing off. It will wait 2 seconds, crashes again, 4 seconds, crashes again, 8 seconds. It will continue to increase this back off timer up to 10 minutes between restarts, hoping that the pod will figure it out, that whatever it's depending on, if it's a database or a cache or some other endpoint, that it'll reappear, a DNS resolution, a human will come along and fix it. Kubernetes doesn't know. But what it does know is that it needs to protect the cluster. And so it's not going to spend a whole bunch of resources constantly starting something that's constantly crashing. We will now delete our pod. Remember, if you have any questions as we're going through stuff, you can add them to the questions panel and I will pause periodically and answer questions. So just as soon as you think of them, put them out there. Launching stuff via manual kubectl apply commands is fine. Like, that's where we all have to start. But it's important that you begin this adventure thinking about how you can set things up to be declarative and repeatable. Declarative and repeatable means if I do something on this cluster manually today, and I go on vacation because we've got the 4th of July weekend coming up and everybody's going on their holidays, and the cluster crashes, my colleagues might not know what I've done. So they're going to have to call me and I'm going to have to come back from my vacation and I'm going to have to fix the cluster, or maybe they won't be able to get a hold of me or whatever, any number of situations. By doing things in a way that's declarative and repeatable, we can use tools for infrastructure as code or configuration management. For example, you're probably familiar with Terraform or Ansible or Puppet or Chef. There was never really anything good for Kubernetes until somebody came up with a tool called Kustomize. Kustomize allows you to template your Kubernetes manifests and keep them under source control. This extends into the idea of GitOps, where the source code repository is the source of truth. So while today we're going to be applying manifests directly to the cluster, in reality, what I would prefer to do is make changes, test them, commit them, push them out to a repo, and have them automatically applied to the cluster. The repository then becomes the source of truth. And if I'm on vacation, my colleagues know that even if the entire cluster melts down, they can restore it to its exact previous state from the repository. Kustomize was built into kubectl back in 1.14, and if you want to use a customized template, you simply use -K instead of -F. I'll show you both formats here in a little bit. And if you want more information on it, well, there's a link right there, kustomize.io. Kustomize it's a big step, especially if this is your first look at Kubernetes. You don't have to start using it right away. Whenever I buy a book on something related to technology, I like to look at the table of contents and I like to look at the index so that I understand what the capabilities of the thing I'm learning are. And then, even if I don't need that feature right now, down the road, when I discover that I do, I know that it can do it. So that's why I want to introduce you to Kustomize today. We have a question from Subhashri who says, where exactly have you run the K3s install command? I ran that from my local machine here, my Mac on my desktop. The ketchup install command then reaches out over SSH as, in this case, the user root, because that's how I have my SSH keys set up, and then it does the entire installation. Kostas asks a great question. What's the difference between kubectl get pods and kubectl get PO? Nothing. Kubectl get pods is the actual full command, but every single resource in Kubernetes has an abbreviation because you're going to type these things so many times that you don't want to type Replica Set all of the time. So it gets abbreviated to RS. You can also do things like KGPO, you can do kubectl get pod / and then a name, or you could do space and then a name. They're just abbreviations. So You've learned about pods, but you're never actually going to create a pod manually for a whole range of reasons. Pods are what we say ephemeral. That was a terrible sentence. We like to say that pods are ephemeral. Ephemeral means that it might be there, it might not be there. And granted, of course, if your application is running, you want the pods to be there, but that exact specific pod might not be there. It might move to a different host. It might get rescheduled. Its IP address might change. That IP might end up assigned to a different pod in the future. Kubernetes handles the abstractions of these things, but you never launch pods. They don't give you a good interface for managing them. Instead, there's a layer of abstraction above a set of pods called a replica set. And while you're never going to create replica sets either, what you're actually going to create are deployments. You need to know what a replica set is. It says right here, defines the desired scale and state of a group of pods. Scale, how many of them are running? The replica set is responsible for babysitting pods of a certain definition. And if you want 1 or 5 or 6 or 3 or 500, it makes sure that that happens. But state, you've probably heard of stateful and stateless applications. And if you haven't, that's cool. We're going to talk about them in a few minutes as well. Kubernetes has another concept of state, which is the desired state and the actual state. The actual state is the actual state. How many pods are there? The desired state is what I tell Kubernetes. So when I apply a manifest to the cluster, for example, I say that I want 12 replicas. I don't tell Kubernetes how to do it, where to put them. I can define rules that say, pods of this type should go on one of these hosts that have this label, but I don't specifically tell it what to do. I just say, I want 12 pods, and it puts them somewhere according to the framework that we've defined. If one of those nodes goes down, Kubernetes recognizes that the desired state is 12 replicas, the actual state is 8 replicas, and it does whatever it needs to do to bring us back to equilibrium between the desired state and the actual state. That's all Kubernetes does. We change the desired state, it reconciles the actual state, and it lives solely to make sure that our wishes are actually done. There used to be a thing called a replication controller that created replica sets, but it was kind of limited in what it could do. So they came out with the deployment controller, which is what we use now. You create a deployment, the deployment creates a replica set, the replica set creates the pods. And that's it. Deployments give you a nice set of interfaces, a nice structure for altering the composition of your pods, as you'll see in a sec. Now, I said replication controller, and I said deployment controller. Kubernetes uses controllers to do things. So a replication controller created replica sets. A deployment controller creates deployments. An ingress controller doesn't create ingresses, but it does things with ingresses. We'll see that later in the class. We only work with deployments today, but deployments are for stateless applications. So I promised you that I would talk about this. A stateless application is something like HTTP. It doesn't matter from moment to moment what pod my traffic lands on, if it lands on one pod now and next pod the next one, if I delete a pod and replace it. If none of it matters, that's a stateless application. And HTTP is stateless. Without things like Redis or session cookies or stuff like that, the web server has no idea who you are from moment to moment. It doesn't know that you're any different from anybody else. It just receives a request, does it, and then forgets about you. There are situations where it does matter. Databases, for example. It matters who the master is. It matters who the replicas are. It matters that the replicas can find the master. The name matters. The IP matters. The storage matters. When you have things that matter, that's a stateful application. And for that, in Kubernetes, you would use what's called a stateful set. Kubernetes also has a daemon set. If you launch a daemon set, one replica goes on every node. So if you have 3 nodes, you get 3 pods, 1, 2, 3. If you add a 4th node, it automatically gets a 4th pod. That's a daemon set. There are also jobs, which is kind of like what we launched at the beginning, where it launches, does something, and then exits, and Kubernetes won't restart it. And then if you need to schedule jobs on a regular basis, there's a cron job, and that does exactly what it sounds like. It just fires off jobs at on schedule. To use that for like backups or pruning tasks or anything that is a batch type of activity. For today, we just go over deployments. And trust me, it's more than enough. Give me a moment here to drink a little bit of my tea. One of the cool things that you can do with a deployment is alter the configuration of the pods running inside it. So for example, we have version 1.0 of our application, and there's 4 replicas, and version 1.1 is out. So we tell Kubernetes, hey, change the version of the container image running in your universe from 1.0 to 1.1. And it begins doing what's called a rolling update. You can configure how many new pods it starts versus how many old pods it kills. You can do one at a time. You can start new ones and kill old ones. You can kill old ones and start new ones. It's all configurable. But for this demo, we have 2 new ones that come in, and then it kills off 2 old ones, and then it starts 2 new ones and kills off 2 old ones, and then we are running on version 1.1 of our application. Should anything go wrong, we can roll this back. And then there's a whole management suite where we can watch the rollouts happen and we can see what's going on and stuff like that. So deployments, what do they actually look like? Well, they look like that. And there's more of that nasty, gnarly YAML. But it's not really that scary. What did we learn earlier? API version. Where in the API definitions do I find information about the thing that I'm asking you to create? Metadata we will talk about in a moment. Spec. If you look at the spec from the template line down, you'll see that it looks very much like the pod spec from before, because ultimately that's what deployments create. The end result of a deployment is a pod, even though there's a replica set in between, but you can just ignore it. Look at the spec. There's a key for containers, and there's a list. And this just has more information about the thing that we're creating. But the basic stuff is there. The name, Nginx, the image, Nginx 1.16 Alpine. Okay, cool. We'll talk about the other stuff when we get into ConfigMaps. Now I could do kubectl apply -f, deployment, blah, 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 blah. But let's look at another way that we can do this. I could do that. kubectl create the deployment, call it Nginx, and run the image Nginx 1.16 Alpine. That's all it needs. And this will actually create the YAML and apply it to the cluster. But what if I just wanted to create the YAML and then edit it? Well, I can add dry run and -o YAML, and it will show me the YAML that it would have applied to the cluster. All I have to do is write that out to a file, go in and edit it, and then I can, apply it or do whatever I want with it. So that's another way that you can generate the YAML. But let's talk about Kustomize. In the deployment base directory, you can see that I have the deployment manifest that I showed you a moment ago, but there's this new file called customization.yaml. This is what Kustomize uses to understand what we want it to do. And this is a pretty simple one. Resources. I want Kustomize to go and just deploy these 2 YAML files. Easy enough. And I also want it to generate a config map. We'll come back to that. You apply Kustomize manifests by using -k and then pointing it at the directory where the customization.yaml file exists. If we run that, it actually created multiple objects for us, a deployment, a service, and a config map. If we run kubectl get deploy, you can see that it's starting to build. And now it's ready. And if I run kubectl get replica set, you'll see that there's a replica set which uses the name of, uses the name of the deployment. Hang on a second here. Sorry about that. Uses the name of the deployment followed by a unique identifier. And if I run kubectl get pods, you'll see that we have the replica set dash a 5-character identifier for that particular pod. Let's look at that. Right now we have something running in the cluster. We've used kubectl get pods. I can pass it the name of a pod, and I can say -o YAML, and it will reach out to the cluster and retrieve the actual YAML for that running object and present it to me. So this is another way that you can get the YAML for something. You see that there are a lot more keys and values and stuff in here, as a lot of stuff was either added from defaults or from the extra information that we have in that particular manifest. So that's one way that we can do it. But that just shows me the YAML. That's the skeleton and the muscle and the definition of the object itself. What about how Kubernetes sees the object? For that, we use kubectl describe. kubectl describe pod and then the pod name. You can do this for anything. You can describe services, you can describe any resource that's running inside of your Kubernetes cluster. This will reach out to the cluster and show us from Kubernetes' perspective what this thing is. Where is it running? What do I know about it? How's, just a whole bunch of stuff. What I like, though, is down at the bottom, this events section. This tells me everything that's happened with this object since it was born. It was successfully assigned to a node. The image was pulled. That was successful. The container was created and the container was started. If you have any problem with a resource in Kubernetes, this is where you start with your troubleshooting. You do kubectl describe whatever the thing is, and you look for why Kubernetes is having an issue with it. And this is different from the application inside of the container is failing. For that, you would actually use kubectl logs, which will show you the standard out and standard error information coming off of the container or the pod itself. What else can you do with the deployments? You can scale up the number of replicas. If we run this, you see that Kubernetes, great. Now we have 3. Before we had 1. That's pretty cool. So let's upgrade this. If I change that from 116 Alpine to 117 Alpine, we can then watch that happen with kubectl rollout status. This will update as there is a change in state. Now, we could actually sit here for the rest of the class, and this is never going to update. Some of you might have noticed why, but let's pretend that we don't know. This is taking a long time to update. Let's do kubectl get pods. Ooh, there's an error. But notice that right now, our original 3 replicas are still running. The site's still up. Customers are still on it. Our boss isn't angry. We're not going to get fired. We have the time to figure out what this problem is. Do you remember the command that we use to ask Kubernetes how it sees the object? Can't actually hear you guys answer, so hopefully some of you have raised your hands and said kubectl describe. Let's go look at this. And let's jump down to the bottom and look at our events. Down here, we discover an error message. Failed to pull image because not found. And we say, oh, I made a typo. It's not Alpine, it's Alpine. Okay. Well, let's just undo our rollout. Now, had the rollout completed, a rollout undo would actually roll it back to the previous version because Kubernetes remembers the changes that you make. In our case, it never started. So doing that just leaves us with our 3 original pods. show you two other ways that you could do this. If you use kubectl edit, just like kubectl get -o YAML, this reaches out to the cluster, brings back the object, and then opens it up in your editor. We can now search for this. We could change that to 117 Alpine and save it, and that would apply it to the cluster. Or we could pretend that we're using GitOps, and we could, for example, edit the deployment, come down here, change 1.16 to 1.17, and reapply it with kubectl apply-k. Notice that Kustomize recognizes that the config map did not change, the service did not change, but the deployment did. And so that's the only thing that it updated. If you're doing work with Kustomize, become familiar with the Kustomize build command. This is a great way to do troubleshooting. If you have a problem with your templates, especially once we start getting into inheritance, which we'll get to in a while, Kustomize build will fail. And then it'll tell you where the problem is, and you can go and dig around in there. Otherwise, it shows you all of the manifests that it would build and that it would apply to the cluster. Let's actually delete that. And let's talk about how we can use Kustomize for different environments. I spend a lot of time on deployments because this is the first major meat of your Kubernetes training. Like, you understand pods, you understand replica sets, but deployments, what you learn here applies to all of the other controllers, all of the other resources, all of the other things that you're going to create. I have two directories. There's the base directory that we were hanging out in a second ago, and then there's the overlay directory. Inside of here, I have a production and a staging. Let's go look at staging. There's some files, but we'll start with the customization file. Here we have some different things. There's a staging name prefix. There's a common label. Then it says it will pull from the base directory that we were in a moment ago, and it will patch whatever it finds there with files in the current directory. And then we haven't talked about ConfigMaps yet, but let's look at what those look like. All right, so image.yaml. Remember that we are 1.16 Alpine, theoretically, in our base. In fact, let me reset that. There we go. But our staging environment can be a little bit more cutting edge. It can run 1.17 Alpine. And if we look at replica count, it's only going to run one replica. But let's go up and look at production. Well, production is a little bit more conservative, so it's going to stay on 1.16 Alpine. But because it's production, it's going to run 3 replicas. The other change that I make is to the config maps. And while I haven't explained what config maps are, let me just show you what the change is. The production environment creates an HTML file that says hello from production. And the staging one just says hello from staging. And in the base environments, it just says hello from nowhere. Each of these customization files has a config map generator, which is going to take that file that I just showed you, that HTML file, and it's going to create a config map called index-some unique identifier. In the case of the base one, you see that it just creates it from the file. Okay. But in staging and also in production, it says replace. There's a number of different behaviors that you can do. You can patch things, you can change stuff. In our case, I just want to replace whatever's from base with whatever I have locally. This will become, the why of this will become clear when we talk about config maps in the next section. So now I can do kubectl apply -k production and staging. And I just created 2 new deployments, one called prod nginx and one called staging nginx. And if we look at our pods, you'll see that we have prod nginx dash whatever and staging nginx dash whatever. We've got our 3 replicas, our 1 replica. They're running different images. I was able to do all of that from that base template by only overriding the specific things that I needed to override for the staging and the production environments. In fact, if I look at ConfigMaps, you'll also see that I have a prod index and a staging index. So let's talk about ConfigMaps. But first, let's check the questions panel. Adrian asks, what's the difference between apply versus create and when to use which? kubectl apply -f or -k points to a file that has instructions in it. kubectl create can create things from nothing. So kubectl create deploy nginx like that. That will actually just create a new deployment with some default YAML running the nginx 1.16 Alpine image. You can say kubectl create -f, and point it at a file, but I don't do that. I always use apply when I want to apply a file, and I use create when I want to create from nothing. In fact, I never use create. I always apply from files, or I do something else. Vishnu says pods and service are the same. No, pods and services are different. We'll talk about services after ConfigMaps. Vishnu says installation for RKE and K3S are the same. No, RKE and K3S are 2 different Kubernetes distributions. We installed K3S with Ketchup. RKE is installed with RKE. RKE is a separate, it's its own binary, and it will install the RKE distribution of Kubernetes, which runs everything inside of Docker containers. For K3S, you need nothing on the host at all. K3S includes containerd in it, and if you use Ketchup, it'll pull down K3S, and all you just need is a host running Linux. For RKE, you need a host running Linux and a supported version of Docker. And then you run the RKE command, and beyond that, it's basically the same, but SSH is in, and it builds you a Kubernetes cluster. It's just what you end up with is a little bit different. Sadaf says, can you show the dry run command one more time? Absolutely. Whoa, kubectl create. There you go. So kubectl create, deploy nginx, pass it the image, -- dry run. Depending on what version of kubectl you're using, you used to just be able to say dry run, but with the 1.18 version of kubectl that came out a couple weeks ago, now you have to say dry run equals client. I don't know why. But if you try dry run equals client and it spits out an error, just make sure that you're running 1.18. If you're not, just dry run is fine. Intranil says, what does normal under type mean? I'm not sure where you saw that. If you can ask the question again and tell me where you saw that, then I'll be happy to answer. But we're going to move on to ConfigMaps now. Imagine that you've got something like nginx. Nginx has a config file, or Apache, or PHP, or anything, MySQL. They've all got config files. And 100% of the time, the config file that ships with the container is not what you need. So how do you fix that? Do you build your own container where you just, from the source container, add your own config to it, and then that's the container that you use? You could do that. That puts you in the business of constantly updating your own container when the upstream container changes, or we're trying to do less work, not more work. So there's another option. You could launch your pods and attach a volume. And maybe that volume contains the config file. Also totally viable. But now you have more moving parts, more opportunities for things to fail. ConfigMaps solve this. ConfigMaps let you override data inside of the container with something that has key value pairs. This could show up inside the container as environment variables, where every key becomes an environment variable and the value is the value. It can show up as files, where every key is a file name and the contents of the value of the key are the contents of the file. You can even so ConfigMap can have multiple key value pairs, and you could just say, take this entire config map and make it a directory, in which case every single key in the config map will become a file in that directory. Secrets work the same way. We don't talk about secrets in this class, but they work the same way. They're handled differently on the hosts themselves. They're only stored in tempfs. They're designed for storage of like API keys and passwords and things like that. Secrets can also be encrypted at rest if you configure your Kubernetes cluster to do that, but by default, they're not. They're just base64 encoded, which they might as well be plain text. Just know that config maps and secrets are similar. We talk about config maps today. The cool thing about config maps is that when the config map changes, it's updated in real time inside of the pod, therefore inside of the containers, without you having to restart the container. So if your application is smart enough to detect the change in a file, for example, and reload it, you can make configuration changes that update your application without restarting your workloads. And that's really cool. There's a debate about whether you want to do that. And there's two sides to that. One is, yes, we want to do that because it's less work, and that's totally fine. If you go down the Kustomize path, though, Kustomize wants everything to be clear and repeatable. So if you are updating config maps in place, then it's possible that the actual running configuration of the workloads in the cluster doesn't directly match, or at least can't be traced to exactly what the current state is from the Git repository. So the default behavior for Kustomize is to create, where's my config maps? Yeah, so you see here, it created a config map, but it gave it this unique identifier at the end. If we were to change the config map, it would actually create a new config map and attach that to the pods, which would generate new pods, which would do a rolling restart across the application. But at least you would know exactly which config map was connected to which pod. There's arguments for both sides. It's up to you to choose which one you want. In fact, let me go back there. And now that you know what a config map does, I can show you in our deployment down here at the bottom. The first thing we did was we created a volume, and we said this volume is called index, and it's made from the config map with the name index. Up here in the volume mounts section, I said take the volume called index, which is defined somewhere else, and stick it here. We could have said take the volume index and just put it at user share nginx HTML, and that would have been fine because there's only one key in that config map. The key is called index.html. That would have become the file name. The contents would have become the file. And that's fine. If you want to change just a single file in a directory with other files, then you need to overwrite individual files. And to do that, you also have to add this subpath thing. This is more advanced config map stuff than what I want to overwhelm you with today. I always get the question of, well, why do you have to list it twice? Because you do if you're just using a single file. What this shows up as is inside of the container. I'm going to show you something else that you can do with kubectl that is amazing. kubectl exec. No. This is another one of those things that they changed, so I have to update my habits. With kubectl exec, it will connect over the TLS connection that kubectl uses to communicate with the Kubernetes cluster, and you can shell into containers in pods in clusters far, far, far away from you. If you can talk to them with kubectl exec, you can shell into them, which is crazy. So you see here this 50x.html, that's actually included in the default container image. So I had to only overwrite index.html, which is why I needed that second configuration. If I had done it as overwrite a directory, this 50x.html wouldn't exist, and Nginx wouldn't start because it wouldn't be able to find the file, and wackiness ensues. But I was able to overwrite the default index.html with hello from staging. And that leads me to services. So we have pods. We can't talk to them, so they're not super useful, are they? I've already told you can't trust pods. You know, pod's going to be a one IP today, a different IP tomorrow, maybe, you don't know. Somebody could add a new node to the cluster, things could get rebalanced, they could get scheduled, somebody could upgrade the application. So you can't talk to the address of the pod, but you need to be able to talk to the pods. Enter services. Services are a logical object. They're not even a real thing. They're just most of this stuff happens inside of IP tables configuration. So a service is a stable DNS endpoint and an IP address. It will always be there. And it's responsible for mapping your traffic to a group of pods. That's pretty much it. Services have 3 types. Each one includes the types that came before it. You have a cluster IP service. This is a service that exists only inside of the cluster. You can't talk to it from outside the cluster, but it's perfect if you have, I don't know, you got a web application that needs to talk to Memcache. Well, you don't need to talk to Memcache from outside of the cluster, so give it a cluster IP, your web app can talk to it, and life is happy. Then there's a node port service. First, it creates a cluster IP service, then it opens a high port on every node in the cluster between 30,000 and 32767. Traffic that arrives on that port is routed and load balanced across the pods. It's pretty cool. You will use node port services when you have an external load balancer that you can't control from within Kubernetes. You've got an F5 big IP or a NetScaler or something like that. HA proxy, who knows? You just point it at the node ports, and when traffic lands on the load balancer, it gets sent to the cluster and everyone's happy. If your cluster is running in a cloud provider and it knows it's running in a cloud provider, and you've done all of the extra magical dance steps that are necessary for the Kubernetes cluster to talk to the cloud provider, you can create load balancer services. This first creates a cluster IP service, then it opens up the node ports, then it reaches out over the cloud provider's API and it configures a cloud load balancer. In the case of Amazon, for example, that would be an ELB or an NLB, depending on, it's ELB by default, but you can tell it to make an NLB. Kubernetes then configures that resource with the hosts and the ports and all of that other stuff, and it maintains that configuration for the life of the service. So if you add new nodes, if nodes get deleted, all of the changes in the cluster are propagated out to the load balancer service automatically. If you're running in an on-premise environment, then you can still do load balancer services using a thing called MetalLB. It's another open source project. It's wonderful. I'm a huge fan of MetalLB. In fact, I frequently make videos about it. MetalLB behaves a little bit differently than a cloud Kubernetes cluster. You can allocate it a block of IP addresses, like a DHCP server. So you say, MetalLB, here's 10 IPs that you can handle. And when you create a load balancer service, MetalLB will take one of those IPs and then it will begin to announce it. It will put it on a host, and it will announce it either by layer 2 ARP or into a BGP fabric if you have BGP running in your environment. And if a host goes down, it'll move the IP to another host and it'll start announcing it from there. MetalLB is wonderful for giving services real IPs for things that don't necessarily speak HTTP, like MQTT or TLS stuff or whatever. Yeah, so that's what services are. And they look like that. They're layer 4 load balancers. They receive traffic on a port and then they just route it across stuff. But how do they find the stuff that they need to care about? For that, we introduce metadata. Here's the manifest for a service. API version, kind, metadata, and spec, once again. Now, this time in metadata, I want you to notice labels and name. Metadata is just metadata. But Kubernetes works off of labels. Labels are arbitrary key value pairs. You can use as many of them as you feel is necessary to accurately identify your applications. And then, notice down here. So in the spec, we've got port 80, protocol TCP. We're going to send it to the containers on port 80. But what pods? What pods are we sending it to? We're sending it to any pod that has the label app equals nginx. And if we go and look at our deployment, you'll see that not only does the deployment have metadata that includes app equals nginx, but the deployment is also using a selector that it will babysit pods that have the label of app equals nginx. And then, well, I'll be here in our template for our pod, we assign the label of app equals nginx. This is how everything works in Kubernetes. Because you don't know what a thing is or how many of them there will be, you label your stuff and then you tell things that care what label they should care for. Labels can be as specific or as vague as you want them to be. For example, in the staging and the production environments, I don't have anything special for the services. So if the staging environment is app equals nginx and the production environment is app equals nginx, well, what's to prevent traffic from spilling across both of them? And the answer to that comes from Kustomize. If you remember, or I'll show it to you just in case you don't, everything in staging got an additional label of environment equals staging. And Kustomize is smart enough to not only put that on the resources themselves, but to put that on any selector. So if we look at staging-nginx-o-YAML, if we look at our staging service, you can see that in addition to the selector being app as nginx, Kustomize added environment staging. So the staging service will only route to pods that have both of these labels. And the production one looks exactly the same, but you'll just have to believe me because I'm not going to show it to you. Now, notice staging nginx. It's a node port service, and here's the port that it's listening on. If we go and talk to that port, ta-da! Hello from staging. That's the config map that I showed you. If we go talk to the other one, ta-da! Hello from production. It's the other config map. So now we've got services. And if we had an external load balancer, well, we could point it at these node ports and everything would be great. But that's not what you're going to do. You like how I teach you things and then I'm like, you're never going to do that. The reason you might do that, but there's another thing that you're going to do, which I'm going to show you next. And the reason you're going to do this other thing is because a one-to-one relationship between load balancer services and applications in a cloud environment is only good for the cloud provider. If you have a cluster that's running 1,000 websites, you're not going to create 1,000 ELBs for $20 a month. Because that's, well, maybe you will. Maybe you don't care about money. But I'm not going to. We solved this problem in the 90s with name-based virtual hosting. Kubernetes has something similar. It's called an ingress. An ingress gets a little fuzzy. An ingress is a set of rules that you apply to the cluster. And they say when traffic is received, they apply to HTTP traffic. So when traffic is received with these parameters, this host name, this path, various other things, send it to this service, and then the service handles it from there. But The rules are implemented by a thing called an ingress controller. An ingress controller listens for ingress requests on the API and configures itself to do whatever the request was. And since it's all HTTP load balancing, these tend to be HTTP load balancers. The most common one that you'll encounter is the Nginx ingress controller. K3s by default uses Traffic, which is another ingress controller. But you can use HA proxy, you can use service mesh, you can use API gateways. There's lots of things that provide ingress functionality. And they look like that. They sit in front of a service and they do layer 7 load balancing. And it looks like that. Kind, ingress, metadata. Annotations are cool. They're another type of metadata that allow you to do specific configuration of the ingress controller when the ingress is actually deployed. So you might have a particular site that needs a different buffer size or a redirect from HTTP to HTTPS, but you don't want to change the entire ingress controller to do that. So you can do it on a case-by-case basis in the ingress with these annotations. This annotation is actually totally unnecessary because we're going against K3s, which uses Traffic, but you would be able to take this and apply it to an ingress controller you'd be able to take this and apply it to a Kubernetes cluster that's using the Nginx ingress controller, and it would work just fine. In our case, it just gets ignored. Our rules are traffic coming in for training-a.cl.monachus on path / goes to the Nginx service on port 80. And if we apply that, well, we created an entirely new site. We now have a dev environment. And if you look at the service.yaml file, actually, let's look at the customization file first. Look at customization. And here we so we pulled from the same base. We're going to use the local ingress.yaml file. We're prefixing everything with dev and setting a dev label. And we're going to patch with the local service.yaml file. The difference being that this is going to create a cluster IP service, whereas our other ones created node port services. So when we run kubectl get service, you see that we now have a dev nginx service, and it's a cluster IP service. And we know that not only because it says so, but because over here there's no high port. This service is only reachable from inside the cluster. But we now have an ingress. This ingress is listening on a public IP, well, public in the sense that it's outside the cluster, and it's listening on this host. So if I were to curl that, we get the default environment. So in a single cluster, we now have 3 applications running: staging, production, and dev, with 2 node port services that would theoretically be attached to an external load balancer and 1 ingress service that's directly attached to a cluster IP service. And that's Kubernetes. So very quickly, let's recap. Pods, smallest unit of thing you can deploy in Kubernetes. They take 1 or more containers, and pods, much of the time, pods have just a single container. That's totally fine. So they take 1 or more containers and they schedule them together so that they share IP space and volumes. Pods are managed by replica sets, which you don't really care about. Replica sets are handled by deployments, which you do care about. So you create a deployment, you end up with a bunch of pods. Hooray! Services expose your workloads outside of the cluster or inside the cluster. They expose them to wherever they need to be exposed so that things can talk to them. And then ingresses do essentially name-based virtual hosting for HTTP. But you might ask, well, what about TCP services? What if I have something like MQTT, for example, and I'm not going to use MetalLB for a load balancer service or whatever? You can, with most ingress controllers, configure a separate config map that tells it how to map TCP ports directly through. Traffic 1.7, which is what K3S uses, doesn't do it, but the Nginx ingress controller does, and Traffic 2, which is the latest versions of Traffic, can also do it. So you would set up a config map that says take traffic from 1883 and send it through to this service where MQTT is listening or whatever. I will now pause to take questions, and then we're going to jump into Rancher. We have a few questions. Indranil says, when you do a kubectl describe, there was a normal. Let's see. Go to your previous question. What does normal under type mean? Event type. Okay. That's a normal event type. This is just a normal state of things. I probably have already scrolled off my errors from before, but I'll bet you the errors that I had. Oh, yeah, waiting for it to finish. Oh, yeah, so it's not actually going to be there because it was inside of a pager. Type would probably be warning or error, would be my guess. We'd have to go back and see. Philip says, how does an external load balancer like F5 get to know the node IPs and ports? You have to tell it. You would handle that configuration the same way you would if you were configuring an F5 to point to a stack of Apache servers sitting in a rack somewhere. F5 and NetScaler, like everybody has a Kubernetes thing. I haven't used the F5 one, but F5, for example, has an ingress controller. I don't know if it's a fully software-enabled version of the big IP, or if it simply exists to bridge between an external load balancer and the Kubernetes cluster. But I guarantee you, every single real player, A10 has a whole thing as well. They bought a company that does Kubernetes stuff. If you have an external load balancer, guarantee you they have something that'll bridge to a Kubernetes cluster so that you're not manually updating configs. Subashri says, I have a cluster created, but I'm not able to access the same with launch kubectl from my Windows machine. Can you please help me to connect to the cluster and deploy my application? So that's too specific for what I can do in this class. If you want to find me on the Rancher user Slack, I am Adrian, and if you can share an error message, I will take a look at it after the class, and I'll try to get you up and running. Oh, wow, that's it for questions. We might even, 2:10? We're probably not going to end on time. We'll try. Rancher. It's actually pretty easy. Okay. There are two ways that you can install Rancher. Let's pop over to the docs here. If you come over to the docs, Rancher 2.x, installing Rancher, there is a production way to install Rancher and a non-production way to install Rancher. And the difference is important. The production way to install Rancher is you install it into a Kubernetes cluster. If you want to get support from Rancher, and remember, everything that Rancher does is free and open source, but we do offer an enterprise subscription for businesses who want support for Rancher, Kubernetes, CNCF software, a bunch of other things, but it's not required. However, if you do want support, then your Rancher server cluster needs to be either RKE or K3S. It's easy. But for today, and if you're doing lab environments, demos, playing around with it or whatever, you can also run Rancher as a Docker container. And that's pretty easy. I have Rancher 2.4.5. I'll explain this in a second. Docker run D for detach. Oh, let's spell that right. There we go. D for detach. Restart is unless stopped. That's important. If you do restart equals always, then you won't ever be able to stop the container, which means you can't ever make backups of it and you can't ever do upgrades of it. You have to delete the container, and if you do that, you no longer have a container to restart if something goes wrong with your upgrade. If you do unless stopped, then you can just stop the container, make a backup, and start the container again, or stop it, do an upgrade, and if that didn't work, start the old one. We punch through ports 80 and 443. And by default, it makes a Docker volume. I prefer to bind mount a directory from the host. I use opt-rancher to var lib rancher, which is the persistent location inside of the container. And I do that because when I want to make a backup, then I can just stop the container, copy off that directory, and start the container again. When you do it with a Docker volume, it's a little bit harder because you have to get into the Docker volume location, and there's that one directory that you can't cd through unless you're root. And so anyway, that's what I do. And then the image that we're running, which is Rancher 2.4.5, is the current stable version. With that, by now, we're probably up and running. We are. Rancher fires up with self-signed certificates by default, but you can bring your own certificates, either self-signed or from a real CA. You can also configure it to generate certificates on the fly from Let's Encrypt. The first thing that you get asked is the Rancher server URL. This is really important. The downstream Kubernetes clusters will reach back into the Rancher server and open a WebSockets connection for maintaining configuration. This is the URL that they reach out to. If you put an IP address here and you change the IP, your life becomes much harder. This has to be reachable, so you can't have the Rancher server in your office and the clusters out in the cloud unless you have a way for them to get back in. It is theoretically possible to change this in the downstream clusters if necessary, but it's a huge pain in the butt. So try to get this right when you do the Rancher server installation. And here's the overview screen. Very quickly, I will import our existing K3s cluster, and then I'll come back and I'll talk about the various other cluster types and some of the global level stuff while we wait for the import to complete. I will select import, I will select training, and I'll say create. It gives me a kubectl apply command that I can run on the, well, not on, but run against my existing cluster to import it into Rancher, at which point Rancher will be able to manage it. Because our Rancher server is using self-signed certificates, kubectl won't actually talk to it. So we need to use this curl command down here. Back on my host here. I always like to do kubectl get nodes if I've changed something around, just to make sure that I'm talking to the right cluster. I have many clusters that I manage and lots of kubeconfig files, and it's really easy to end up pointed at the wrong cluster. So I'm pointed at the right cluster. We'll run this. Sometimes it gives that no objects passed because something goes wrong with the curl command. But there we go. It created a bunch of objects. And now back in the browser, if we say done, this is pending and it will install the Rancher agent, and then this will come up and be active in just a moment. If I click add cluster again, I want to talk about the other types of clusters you can create. Down here at the bottom, you have hosted Kubernetes providers. These are a great option if you don't want to manage the control plane. EKS, AKS, GKE, and there's others that we support as well. We just don't have the drivers enabled by default. You can either launch them directly from within Rancher, which means you give Rancher the cloud credentials to go and do that provisioning, and it will reach out to the cloud provider, provision the clusters, wire them back into Rancher, and do full lifecycle management. So you can add and remove nodes, you can delete them, you can do all of this stuff directly from within Rancher. Alternatively, you can spin up infrastructure. Similar, you give it cloud credentials, but instead of launching a hosted cluster, it will actually provision cloud instances, install Docker onto them, and then install Kubernetes, and then wire that back into the Rancher server. And we have a handful that are enabled by default, but I'll show you in a second where you can enable the others. You already saw me do an import, which is If you have Kubernetes clusters already running out there in the wild, you can just import them into Rancher. Problem solved. And for everything else, there's custom. A default installation of Kubernetes, if you use like kubeadm or something like that, requires that you do all of this provisional work on the nodes before you can even install Kubernetes. You probably have host provisioning with Terraform, Ansible, Puppet, Shep, things like that. And when you deploy RKE, all we need on the host is a supported version of Docker. That's it. So you can use autoscaling groups, Cloud Init, any of the other stuff that I mentioned. You can do all of your host provisioning and configuration, and then just install Docker. And at the end, when you go through these steps here, and I say next, you'll see that it gives me a Docker run command down here. Make this a little bit bigger for you. It gives me this Docker run command. And if you see when I change these values up here, it just adds flags. And if I were to expand advanced options, I get some other info that I can add here, which just becomes more flags. This Docker command is unique to this cluster. So you can put this at the bottom of your provisioner, and when you add and remove nodes, well, when you add nodes to the cluster, they automatically join the cluster and they show up here in Rancher. So you can use this. This is in fact my preferred way to launch clusters out in cloud providers. If I say done, I have to actually delete that because otherwise it's just going to sit there. I just want to make sure I was not deleting the wrong thing. That's taking a really long time. I'm going to go look really quick and see why. What's going on out here? Oh, okay, well, it's pulling the image. I don't know why that's taking so long. I run a caching server locally. So whatever, I'll just continue to show you what's going on with Rancher and eventually, waiting for API to be available. Okay, so it'll be ready in a minute. At the global level, Rancher is responsible for managing hundreds or thousands of Kubernetes clusters, and they would all show up here. So there's a bunch of stuff at the global level that you can set to apply to all clusters. The first one is authentication. That's a little bit big now. If you connect Rancher to any of these backend identity providers, then all of the users and groups from that provider are available for you to use in Kubernetes role-based access control configuration. You can set under roles here, you can either use the roles that we've provided for you for global, cluster, or project, or you can add new roles that inherit from existing roles, and you can get super, super granular. This is, I think, the strongest feature that Rancher provides for the enterprise. Because, well, imagine this. Imagine that you're in the IT ops department and you manage Kubernetes clusters for a bunch of teams in your organization. Who knows, hundreds of clusters, dozens of teams, and everybody needs access to different things. And they've got clusters in Amazon and Google and under their desk and in the data center and out at DigitalOcean. And somebody joins the organization. You have to figure out, well, what do they need access to? And then you have to go to each of the providers and you have to configure some IAM credentials and some Azure credentials and some local credentials. That's an opportunity for human error. Plus, it's not very much fun. When somebody leaves the organization, you then have to figure out what did they have access to? And you have to go to all those places and you have to remove access and you have to hope that maybe you got it all. All of that goes away with Rancher. If they join the organization, you just put them in the group in Active Directory or whatever, the GitHub organization, and they instantly have access to any cluster that group can access. And if anybody leaves the organization, you just disable their account and they instantly lose access to everything. All of the authentication happens within Rancher. It becomes an authentication proxy for communication with downstream clusters. This is a part of the class where my voice starts to get hoarse. So this is super cool. And if you don't have a backend identity provider, you can even configure users here locally and still use Rancher as an authentication proxy. Oops. drivers. Here you can see cluster drivers that we support, but that are disabled by default, and same thing with node drivers. So if you want, for example, if you work with OpenStack or Packet or something like that, you can activate those, and they'll be available for you to do infrastructure deployments with clusters. All right, let's go talk to our cluster. Here we go. This is our cluster. Our cluster has two projects by default. There's the system project and the default project. Projects are something that I don't really get into in this class, but well, very quickly. Kubernetes uses a thing called a namespace to group things together by name. So any resource has to be uniquely named within a namespace. You can't have two deployments called Nginx because, well, that's two things with the same name. But you can have two namespaces, one called production and one called development, and you could have a deployment called Nginx in each of them. The namespace becomes the boundary for role-based access control within Kubernetes. And if you have a large organization with lots of namespaces, you're back in the place where you're adding and changing things in lots of places. Rancher solves this by collecting namespaces into a project. And so here, for example, you see that the system project has 4 namespaces within it. We then apply role-based access control configuration to the project, and it automatically gets applied to all of the namespaces underneath it. If I have access to the default project and you have access to another project that I don't have access to, when I log into the cluster, I won't see your project here, and you won't see my project. It only shows you what you have access to. In the default project, you can see that it imported all of our existing workloads, and that's super. But what if we wanted to deploy something manually? For example, let's say that we wanted to deploy a new application for our customer. I know that this listens on port 8080. I want that to be a cluster IP service. I want to set an environment variable of cow color equals yellow. Or I could inherit environment variables from ConfigMaps or secrets. And there's other things that we can do here that, for example, we can do a health check. Make sure that get slash on port 8080 returns something good. Otherwise, it'll get removed from the service. We can attach persistent volumes. We can expand this link down here in the lower right, show advanced options. And this gives us access to more advanced configuration for the workload, where we can set all sorts of stuff. But I'll say launch. And this is going to go and launch. Anything that's launched, anything that's running, well, we can just go in and we can edit it the same way. So we could change the image here like we were doing earlier. We could change the ports, we could change variables. This is designed to get people very quickly to the point where they can use Kubernetes without necessarily knowing all of the core fundamentals of what Kubernetes can do. You can drop somebody on this and they can pretty much figure out, oh, okay, I want to go deploy some stuff. And they can be up and running. But it also doesn't hide anything from you. Over here in this menu, I can say, well, view edit YAML. And here's all of the YAML for whatever my resource is. So I can change stuff in here. Like this has, where's replicas? Replicas 1, I can say replicas 3, and save that, and it'll do a rolling update. I can change the image. You can do all of that stuff. We launched our Rancher demo service. Let's click this plus sign over here and scale that up to 3 replicas. It automatically created a service for us there, the Rancher demo service. And if we come over here to load balancing, well, we already have that ingress that we created, which is on this host name, but I want to change that now to point to, we'll add a new service here. We're going to say slash goes to the Rancher demo service on port 8080, and I'll say save. And now if I were to click this, it actually takes us to our application. And here you see the 3 replicas and you see the little green flag as it load balances across them. And this is our app. But our client comes and our client's like, oh, we're allergic to the color yellow. We can't have that. Okay, no problem. So we can just say edit come into the environment variable and change this to pink, for example, and say save. And Kubernetes will now do a rolling update. And if we hang out here for a second, we'll actually see the pink containers start to roll in. And when that's done, the yellow containers will roll out. But since we're short on time, I'm not going to wait for that to happen. Let's talk about the other stuff that goes on over here. Rancher ships not just with things for making the management of Kubernetes easier, but also a bunch of additional CNCF applications to really make your Kubernetes cluster useful from the beginning. For example, back out here at the cluster site, if we go to notifiers, we can add notifiers for Slack, email, PagerDuty, webhooks, or WeChat. And once those notifiers have been added, we can attach them to alerts, or we can create new alerts. At the cluster level, we ship with monitoring for all of the cluster components, so you can get alerts on etcd failures or scheduler problems or various other things. And within each cluster, you can also set up alerts for the individual workloads running in the project. You can also do cluster and project level logging to any of these endpoints, and it can be independent. You can send cluster logs to one place and project logs to somewhere else for each project. If you don't have CI/CD system already deployed, you can plug Rancher into your existing repositories, and you can automatically deploy and upgrade applications based on code changes in the repos. And Rancher integrates with Helm. Helm is the package manager for Kubernetes. If you've encountered Helm before, there are places, Helm repositories, where you pull down charts that have instructions on how to build complete applications. You can automatically use anything from Helm within the app catalog, but Rancher also ships with a curated list of apps that we ourselves use and that we maintain the charts for. If I open up something from Helm, so let's actually just jump into something down here. Let me give you the Hadoop story. Let's say that I'm a developer and I'm building an app and I want it to talk to a Hadoop cluster. But I don't necessarily know how to talk to Hadoop. I don't know how to deploy Hadoop. I don't know how to do it in containers or Kubernetes, nor do I care because that's not my job. I can come over here to Rancher and I can say, I want to deploy a Hadoop cluster. And the difference between a regular Helm chart and a Rancher app is that with a small modification to the Helm configuration, instead of it just being key value pairs to configure it, we provide you with this really nice form. So anybody can come in here and answer these basic questions or just accept the defaults. All of these things are substituted in with variable substitution. Let me find something here. There you go. And when I click launch, if I had enough resources in my little cluster here, within about 10 minutes, I'd have a 5-node replicated Hadoop cluster, and it would hand me back an endpoint that I could just plug into my app and I can get back to work. It saves hours of time and gets people moving quickly towards where they want to go. I know that we got a minute left before I'm supposed to be done. I'm probably going to go another 10 minutes, depending on the number of questions that we have. If you do have to drop off, this is recorded and you'll get a link to the slides in the video afterwards. But if you can stay for another few minutes, please stay. So those are the apps. And then there's advanced level stuff that I don't cover in this class, but you should know that it exists. Horizontal pod autoscaling allows you to configure the threshold for CPU and memory utilization in your application, at which point Kubernetes will scale it up. So you might have 5 pods running and you start to get a bunch of traffic and Kubernetes scales it up to 10. All of that configuration happens here with HPA. Pipeline, as I already showed you. Istio, you can, with a couple of clicks, deploy an Istio service mesh into the cluster and then activate it on a project by project basis and do all of the configuration of Istio from within Rancher. Your config maps are here, and you saw me create those. And then secrets behave basically the same way, but there's different types of secrets. There's certificates and registry credentials as well. All right, that's Rancher. And I know that there are some questions, so let me go through the questions and then we'll wrap this up. Vishnu says, what if we lost the kube config file? Ooh-wee. Okay, that's a very good question. When Rancher is your auth proxy, when you have your clusters attached to Rancher, you can generate your kube config file up here in the top right. I didn't even show you this. First of all, you can run one-off kubectl commands directly from this little included shell, or you can say, give me a kube config file. And you'll see that this actually connects through the Rancher server. I'm not sure if you can see that. It's kind of small on the screen. This is a kube config file for you. So it has the role-based access control and authorization and everything for you. When you connect with this, Rancher authenticates you, and then sets impersonation headers and passes your traffic to the downstream cluster as you. And then according to the role-based access control configuration of the cluster, it'll decide whether or not you're allowed to do what you've asked it to do. A benefit to using Rancher is that you can always just come back in here and regenerate this kube config file. So if you ever lose it, that's fine. It's right here. In general, though, your kube config file for your cluster is really important, and you should keep that safe. Don't lose it. Don't share it. Don't post it anywhere. It's really important. So back that up. Kostas wants to know about the nice autocomplete in iTerm. Yeah, I get that question a lot as well. That's actually fish. So if you see as I've been typing things, it starts to fill in. One of my favorite things about fish is that it does history, but it's context sensitive. It knows the directory that I was in, and it shows me the commands that I used most recently in that directory. So it makes it really great for CDing into a project directory, and suddenly I have all the history for everything that I typed in there. The other thing that I have it bound to is FZF. If you're not familiar with FZF, it's a fast fuzzy finder. So you can do find.pipe FZF, and there's really nothing here. Let me just jump out there. Okay, so if I do find dot, I pipe that to FZF, then it starts to show me, you see how fast it's going through things, and then I can do fuzzy searching. So if I wanted to look for everything that was readme.md, well, then it shows me everything that's there. FZF is amazing and is bound to Control R. So I can do Control R, and as I start typing, it figures those things out. So those are two of my shortcut tricks. Deepak, can we get a recording? Yes. Everything that you see, so Zoltan says, is this interface available only for enterprise customers? Everything you see me doing today is free and open source. Rancher's not open core. It's not like you get some things and you get more if you pay for it. 100% of the product is 100% of the product. Our enterprise customers get the exact same product as you. They just get services on top of it for support and a bunch of other stuff. Thank you, Deepak. Deepak gave me a nice compliment on the quality of the training. I work really hard to make these trainings relevant and to still make them fun. So I'm glad you appreciate it. Lost the kubeconfig file before adding to Rancher. Is there a way to regenerate the kubeconfig from the cluster? Vishnu, is this a K3S cluster? Let me know in the questions. If so, yes. Deepak says the pricing listed on the website are GPL. Well, I don't know what pricing you're referring to. Deepak, let me know what you're talking about there. Oh, it's an RKE cluster. Vishnu. Yeah, if you lost the kubeconfig file and if you lost the cluster, do you have the cluster.rke state file? If you do, you might be able to, as long as you have the cluster.rke state file, I think you can regenerate it. Hit me up on the Rancher user Slack after the class and we'll try to test that. Eternel, you're welcome. All right, I'm getting more thumbs up. Okay, Deepak, I see you're asking me about price lists. Deepak, please find me on the Rancher user Slack. If you want to propose this to a customer, If you want to be a partner and like a managed services provider, then yeah, hit me up on the Rancher user Slack and I'll put you in touch with somebody who can take care of you. Alok is asking about how it's priced. So I don't talk about pricing. I am the director of community and evangelism. I am strictly here to give you guys Rancher for free. But if you want to talk to somebody about pricing, ping me on the Rancher user Slack, and I will put you in touch with somebody who will answer all of your questions. Oh wow, the questions are just flooding in. Okay. How would you share the recorded link? You'll get an email. Whatever email you use to register for the session, you'll get a follow-up email that thanks you for attending and gives you links to the resources. Clifford wants to know the system specs needed to install in a test lab. You don't need a lot. What you see me using here, whoops. So this is in my house. I have a 5-node Proxmox cluster. This particular node is running, it's probably got 2 cores. Yeah, so I've got 2 cores and 4 gigs of RAM, which is more than enough. You see that with K3S running. I mean, I've been using, I've got 3 gigs in cache. K3S will run fine on a node with 1 core and 1 gig of RAM. The Rancher server wants a little bit more. And to start with, so this guy has 4 gigs of RAM as well and 2 cores. And that's fine for managing a small cluster. But the more clusters that you have it managing, the more it needs, because it launches a different, it's called a node controller. It launches a cluster controller. It launches a cluster controller for each cluster, and that uses resources. So once you start managing a cluster of like 3 or 4 nodes, you want to take your Rancher server and kick it up to like 8 gigs of RAM and a couple of cores. And then just keep an eye on it. And as you see it starting to use more memory, you'll have to grow it. If you have a Rancher server cluster that's managing hundreds or thousands of Kubernetes clusters, it's going to be a fairly large cluster. And the specs for that, if they're not on the docs site somewhere, find me on the Rancher user Slack and I will get you that information. All right, everybody's saying thank you. You are all very welcome. I'm really glad that you enjoyed this. What CNCF ecosystem can we expect to be included in RKE support? All right. So RKE support is actually just RKE, but Rancher support includes all of the Rancher components, the Docker engine, the Kubernetes components themselves, and every single bundled application. So that would include Istio, Prometheus. The pipeline engine is based off of Jenkins. So all of the CNCF stuff that's bundled with Rancher is also 100% supported. And by 100% supported, it's 100% supported. If Prometheus is doing something bad, you call us. If you need help with it, you call us or you open a ticket. If something goes wrong with your cluster, you open a ticket, we do troubleshooting with you. If it's something in Kubernetes, we take it upstream to Kubernetes. And if they can't fix it fast enough, we will release a patch that you can apply to your cluster that is a workaround to solve the issue until upstream can get it patched and released. We do everything to keep your Kubernetes clusters running. More questions. All right, we're going to settle in for the questions until they stop coming. Does Rancher require any database? Rancher is an application that runs inside of Kubernetes. So the HA functionality of Rancher is delivered by the HA functionality of Kubernetes. In the case of RKE, if you have a 3-node RKE cluster, that's using etcd for HA, done. In the case of K3S is a little bit different. Because it's so lightweight, its HA component is delivered by an external data store. So if you want K3S to be HA, you would point it at an external etcd or an external MySQL database. Because really, Kubernetes doesn't do anything special with data storage. It's just key value pairs. So a SQL database works fine for that. That makes your K3S cluster HA. And therefore, Rancher deployed in K3S is also HA. Rancher itself doesn't require anything other than the functionality of the Kubernetes cluster. Clifford So Clifford found slack.rancher.io. Yeah, I have closing slides that'll repeat all of this stuff. In fact, I'll fire up some resources news there across the bottom of the screen while I continue to go through questions. Zoltan wants to talk to me about Proxmox. Hit me up on the Rancher user Slack. I'd love to talk to you about Proxmox. There is not a cluster driver for Proxmox in Rancher, but it's just, it's KVM. It's not anything special, so I imagine there's a KVM driver. So the node drivers, okay, this is interesting. The node drivers, if we come back out here to global and come to tools, drivers, node drivers, you can add a node driver. These are Docker machine drivers. So if there's a Docker machine driver for KVM, it'll probably work with Proxmox. I don't do infrastructure deployment from within Rancher. I build my clusters myself. Well, not the clusters, but I provision the nodes and I do all of the provisioning with Ansible. And then I import them or I turn them into custom clusters, depending on whether they're K3S or RKE. How to create a cluster on Windows 10. Okay. Come out here to add cluster. And Windows clusters are supported within Rancher. You will create a custom cluster. And let's call this Windows. And down here, there's this section, Windows support, right here. Windows support is available with Flannel. I know that technically Calico is supported for Windows clusters right now. We don't have that support in Rancher yet. So if you want Windows, it's Flannel. At which point you can say enabled. You get some additional options here. Do you want VXLAN or host gateway? And then you would say next. When you're deploying a Windows cluster, now you have two options at the top, Linux or Windows. A Windows Kubernetes cluster still needs Linux nodes for the control plane, and it still needs one Linux node for the ingress, but the remainder of your workers can be Windows nodes. So you'll first click Linux, and you'll set etcd in control plane, and take off worker. You'll set etcd in control plane, and you'll go and deploy those as Linux. Or you can combine them if you want, depending on how many nodes you have available. But let's just say that you're building a production cluster. So you have 3 nodes that are going to do etcd in control plane. Boom. You take this, copy it, paste it into your nodes where you're running Docker, and great, you've got a control plane. Then you're going to come back over here, you'll uncheck these, and you'll check worker, and you'll deploy this on your one worker node that's going to handle the ingress controller. After that, you come back over here to Windows, and Windows nodes can only be workers. And notice that this command changed to a PowerShell command. You'll go and run this on your Windows workers, and they will provision and join the cluster. All of the information on how to do deployments of Kubernetes in Windows is down over here. Launching Kubernetes on Windows clusters. This will walk you through, step by step, everything that you need to know. Subhashri says, my cluster has the provider as custom version 1.16.4, so it will be RKE. Sean says Proxmox is great. Proxmox is great. I have a 5-node cluster. I'm running on 4 nodes from Protectly. There are these cool little fanless systems. And then I've literally got a Mac Mini from like 2010. It's got 6 gigs of RAM in it. It won't even run Mac OS anymore, but it makes a fine Debian node, and it's one of my Proxmox nodes. Vishnu says, please mention my Slack name along with the video mail. Yeah, I should probably put that in the news crawler at the bottom. I am Adrian on the Rancher user Slack. Let me just jump back out to there in case more people have to drop off, because I know we're running really long. I'll tell you what, let me finish the rest of the slides here, and then I'll go back to the questions. And any of you who want to stay and continue to ask questions, I'm happy to just continue to stay. I built the Rancher Academy in the first part of 2020. We launched it in May. It is a comprehensive course on everything for deploying Rancher into Kubernetes and then deploying and managing Kubernetes clusters with Rancher. It's a certification course. If you spend 3 to 5 hours a week on it, you will finish it in 5 weeks. But you can finish it as fast as you want. It ends with a final exam and a certification that you can use to show employers, colleagues, anybody at all that you have been certificated by Rancher with the knowledge to go forth and manage Rancher and Kubernetes in a production environment. Within the first day, we had more than 1,000 signups, and it's been active now for, I think, going on 6 weeks. We have more than 5,000 people enrolled. We've issued more than 700 certificates. It's extremely popular, and there's a channel in the Rancher user Slack called Academy where there's a lot of conversation about stuff related to learning Rancher and helping one another pass the course. This is also completely free. You can go to academy.rancher.com and sign up. And then continue your training with Rancher. Remember that Slack exists. If you don't have an invitation, you can go to slack.rancher.io. If you do have an invitation, you can still go there, and there's a link that says if you already have an invitation, click here. Otherwise, it's just the Rancher-users workspace in Slack. And then, of course, there's me. If you enjoy the way that I teach, I also make YouTube videos, both for Rancher and for myself. In fact, here's a link for the Rancher Academy. I manage Rancher's YouTube channel, so I'll put content up there, and then that's where this video will end up, and so on and so forth. My YouTube channel has things that are Rancher related, Kubernetes related, technology related, Metal LB, whatever I feel like doing. I live in South America. I have a 7-acre piece of property down here with a photovoltaic system. That's, a huge lab. I talk about green energy. Like, it's fun. I'm not your normal IT guy. So if you like that, you can come subscribe to my channel too. And the next slide's actually going to say thank you, but I'm going to come out of it and come back to the questions. All right, let's continue with questions. Is there a security scanning capability within Rancher or RKE? That's a question from Sean. Yes. In Rancher 2.4, here, tools, CIS scans. This is only available for RKE, but this will do security scanning of RKE clusters according to the latest CIS benchmarks for Kubernetes security. You can get more information about this in our documentation down here under the security section, where there's not only information about the security scans themselves, but there's also information about how to harden your systems and your RKE deployments according to the version of Rancher that you're running. So this is current up through 2.4. Philip asks, is there an advantage to provisioning the cluster VMs yourself? Why not always let Rancher provision the cluster? I'm old school. I've been building internet infrastructure since the mid-90s, and I like control. So I have my own idiosyncratic ways of the way that I like things built, the packages that I like to be installed or not installed, my fish environment, how SSH operates, all of those things I want. I want that level of consistency across all of my personal infrastructure. So I have Ansible playbooks that set all of that stuff up for me. And that's just how I like to do it. There's nothing wrong with letting Rancher do the provisioning for you. And in fact, in a cloud provider environment, there's an argument for letting it do that because it will just install the minimal amount of stuff and maybe it'll be more secure. There's a direction that the industry is going towards immutable infrastructure where you can't even log into the nodes. And we have a project that we're developing called K3OS. Which is an operating system built for K3S, where you control the operating system from Kubernetes. So you can literally do like kernel upgrades and package updates and everything from within Kubernetes. This is still under development, but it's so totally the future. It's amazing. So that's K3OS. You can check that out. Does Slack use same credentials as Academy? At the moment, no. Slack is independent. We're considering building like an SSO system for everything, but it's just not a priority right now. Hey, Sean has 4 NUCs. NUCs are cool. I considered getting them, but I really wanted fanless systems. I don't think NUCs are fanless. The Protectly systems. These things are super cool. They get hot, but they can run up to, you know, like 50 degrees Celsius or something like that, and they're just totally fine. There's no moving parts, and because they're totally silent, they pass the wife test. Back in the old days, I had tower computers in my house, and you know, I fall asleep to the like fans running. I don't know how I can still hear. Okay, that's it for questions. So, I already did my outro. I will show you that last slide again, but remember, you're going to get a copy of the video. You're going to get a copy of the slides. Find me on the Rancher user Slack. I am the director of community and evangelism, which means I am here to make you succeed, not make you. If you don't want to succeed, I'm not going to make you, but I'm here to help you succeed. Hopefully you want to, and to help you deploy Rancher, use all of our stuff, solve your Kubernetes problems. I mean, there's a limit to the amount of attention that I can provide. But I want the community to grow. So find me, ask me questions, and you know, let's take over the world. And with that, if there are no final questions, which there are not, I will go to my closing slides. I already did that. I will go to my outro, and I will say thank you very much for joining me. And I look forward to seeing you in a future training. I hope you enjoyed the class. Thanks for staying late. Take care of yourself. Have a good weekend.